So in general on the GRE, if you see an exponent problems, the first thing to recognize is that almost always they will give you expressions or powers that are powers of some common basis. And they would typically be 2, 3, 5, or 10. In this case, you'll notice we have 8 and 4, and both of these can be expressed as powers of 2. So the general strategy is to always write the expression in terms of a common base. So for example, 8 to the 10, I'm going to write it as 2 cubed to the power of 10. So I'm replacing 8 in terms of powers of 2. That becomes 2 to the 30. Same thing I'm going to do with 4 to the 10. 4 is 2 squared, so that becomes 2 to the 20. So the first step in this would be to write the numerator in powers of 2. And we're going to do the same thing with the denominator. So 8 to the 4 plus 4 to the 11. I'm going to do 2 cubed to the 4th, 2 squared to the 11. This becomes 2 to the 12 plus 2 to the 22. Now, when you see sum of exponent terms, the other thing to always keep in mind is you can't add these, meaning 2 to the 30 plus 2 to the 20 is not 2 to the 50. That's the most common trap. And same thing, we can't do that here. What you can always do is to factor the largest common term. So here in the top, we're going to pull out 2 to the 20. And think of what would be left behind when you pull out this term would be 2 to the 10, and this would be 1. If you ever need to check your work, remultiply and check if you get the same expression. Same thing with the denominator. We're going to pull out 2 to the 12, and we get 1 plus 2 to the 10. You'll notice that these two are the same. Those drop out. We're left with 2 to the 20 over 2 to the 12. Subtract the exponents, and that becomes 2 to the 8. And not to forget that we have a square root, which I haven't introduced so far. So square root of 2 to the 8, which is really 2 to the 8 over 2, because that's a half. That becomes 2 to the 4, which is 16. So the answer is B.